Here at Powersafe, it's all about the safety factor for us. So it's about meeting the standards and exceeding the standards, making sure what we supply our customers is going to last them 10, 15, 20 years on site. From the new standards that have come out, 61439, the most critical aspect to switchboards now is their thermal management and making sure they're rated to meet the componentry requirements. So what we've got here is our thermal testing chamber. So what we do here is we heat this chamber to 40 degrees to mimic outside, out west, on a mine site, on a construction site, copping sunlight, those sort of things. We've got probes set up on the RCDs, MCBs, internal wiring, all recorded here. So this records all your temperatures throughout the whole test. What we do then is we've got load banks, all different single phase load banks, some 3-phase load banks, all plugged into the board. And what we do then is we turn these on, we get them all cranked up to pull the full load amps out of the board. So what we've got here is a 63 amp board. So we crank up the 3-phase, we get the single phase going to pull that whole 63 amps out of the board and monitor those internal temperatures. On this board here, with no thermal management, you won't be able to do that. The componentry will overheat. So what we do is we've got to come to our rated diversity factor, which is basically just a rating on the board to say, okay, you can pull X amount of power out without overheating the componentry. So for this board here, it's an RDF factor of 0.4. And the way we get to that is we run the power in through the board, we load up all the individual circuits, and we find what percentage of the total load can the board take without any of those components overheating. And for this board, it's 40%. So it's 40% of that 63 amps can be used. So if that's going to a site with sporadic use, that board as it sits would work fine. If it's going to a mine site where they're doing welding, using heavy equipment, you will then use our thermal management system on that board, which will allow you to pull the whole 63 amps while maintaining the board below that specified temperature range. That temperature range is guided by your individual componentry. So the manufacturer of all these parts gives you a temperature range which it can operate to. So your RCDs are your single phase safety switches. So they're rated to 75 degrees. So you can pull any power through those up to 75 degrees. So with the lid on it like this, no thermal management, you can only pull about 12 amps through those. After 12 amps, they'll start to overheat. So every time you pull power through a device, whether it be through a cable, through a safety switch, it generates heat. For our power boards, we're putting in their oversized conductors for all our internal cabling. It's rated to 125 degrees, the conductors we use within that. All the RCDs and componentry we use is at the top of the market. These are all rated at 60 degrees for the RCDs, 75 for the RCBOs. A lot of your domestic products are only rated at 40 degrees. So if there's a manufacturer out there and they're using domestic switchgear in there, by the time you put it out in the sun, she's cooked. You can't run any power through it, you're going to overheat those components. If you do go over that temperature rating, you can start getting failures in this. You can get cables melting internally, which can lead to fires, can lead to arc flash, and damage any components that are plugged into it. So if you've got sensitive equipment plugged in, you'll get surges down the line and that can damage that equipment. So it's all about making sure you use the best quality components you can, the best internal components you can. It's all backed by those manufacturers as long as we stay within those temperature ranges, and this is how we prove it.